Hey there, it's Jason Gorman from Codemanship with a video about specification by example for C# developers. In a previous video in this series, we asked the question, what tests should we write? It's something that confuses a lot of people who are new to TDD. And quite often people mistakenly believe that their goal is to write tests for every method and every getter and setter. But in that video, we talked about why it's important that your tests are meaningful. They should be about outcomes for our customer or end user outcomes. So not about design details like getters and setters, for example, but about things customers want to happen. And in the process of driving a design that gives them that outcome, those details will naturally fall out in the design process. And the other thing we talked about was a pattern that's described in Kent Beck's book on TDD, Test-Driven Development by Example, which he calls a test list, which is, as the name implies, just a list of the tests that we think we might need to pass in order to complete a requirement or solve a problem. To illustrate that, I used our CD warehouse example. So here's some requirements that I was emailed by my customer. They are suitably vague, as they often are. And what I did was I read through those and I sort of parsed those requirements and identified 4 use cases. And then for each of those use cases or user stories, I thought about what scenarios the software might need to handle. So there's the happy path for buying a CD, for example, when it's in stock, but what happens when it's out of stock, or what happens when their credit card payment is rejected. And that is a very useful exercise to go through. So you're thinking about exactly kind of what's going to happen. But still pretty vague, isn't it? So what actually happens when we buy a CD that's in stock? What are the actual outcomes there? So we still got to put more flesh on the bones, as it were. There's still room for misinterpretation here. And that room for misinterpretation, that ambiguity, can work out very, very expensive. If you look at the average team's defect database, at their bug tracking system, you will often find that the majority of the bugs that are reported are actually what we call requirements defects. They're misunderstandings about the requirements. And there's 2 ways that we can test our understanding of the requirements to discover these defects. One way is to build the software the way we think it should be, and then give that to our customers and go, what do you think? But it turns out that's a very, very expensive way of testing whether you've understood what they're asking for. The cost of fixing bugs, including requirements bugs, misunderstandings, rises exponentially the longer they go undiscovered. So if we were in a room talking to our customer about the requirements and we discovered the misunderstanding there, then it's very easy to correct. It costs almost nothing. If we actually go forward and build the software based on that misunderstanding or that wrong assumption, it can cost 100 times or 1,000 times more to fix. And teams that rely on getting feedback about requirements by delivering software, essentially by building it and seeing what the customer thinks, tend to end up spending the majority of their time fixing those bugs. So downstream, they waste a lot of time. Much smarter, I think, to test our understanding of the requirements up front before we start writing code, when those misunderstandings are much easier and much cheaper to clear up. So what I've done here is I've created a spreadsheet for this particular user story by a CD. And inside this workbook, I've created worksheets, one for each of the scenarios. There's an extra one there. We'll talk about that in a minute. One for each of the scenarios that are described in our test list. What I would do is I would take the customer, the person who wrote that requirement, the person who wants that feature, and I would find a quiet space somewhere and sit down with them, and we would start fleshing it out. And the way that I would do it is, first of all, I'd ask them to sort of describe in nice, friendly English language terms, or whatever language you both happen to speak, how they think that particular scenario will work. Now, I've captured this in the spreadsheet in the friendly given when then style that is beloved of behavior-driven developers. So if you're into BDD, this is the kind of format they use. The given is just the setup for the test. So given a CD that's not in the top 100, we'll describe why that's important in a minute. And we have it in stock, so that's the scenario we're talking about. And here's an implied detail that we didn't capture in the test list, and the customer's card payment will be accepted. So we're taking that as given for this, hence given. When is the action that we're testing? When the customer buys that CD. And here's the important stuff. These are our tests. One copy is deducted from the CD stock and the customer's card is charged our price for that CD. And the charts are notified of the sale. So we're putting some real meat on the bones here, getting a much better understanding of what this particular scenario is all about. And we've already identified things that we didn't think of when we were just going through the basic requirements text. Now, the whole top 100 thing, why does the chart position, there's the chart position of the CD, why does the chart position matter? Well, in the process of having this imaginary conversation with my imaginary customer suddenly remembered that they have a price guarantee for chart albums. So if an album is in the top 100, they guarantee to beat the best price of any of their competitors by £1. So in this particular scenario, these albums are outside of the top 100, so that doesn't apply. But we've added an extra scenario here, plus some extra test data, to describe what should happen, how much should be charged to the customer's credit card when the album is in the top 100. So we discovered something that we didn't understand about the requirements, or something that the customer had forgotten, and now we've had a chance to capture that and to rectify that. So we've effectively fixed a bug in our understanding, but we've done it very, very quickly and very, very cheaply. So that's the power of this conversation. What we do is, once we've captured each scenario, though, because again, there's still question marks here. What CD? What is its chart position? How much stock is there? And so on and so forth. So we fill in those gaps. If you think of those as being like parameters of a parameterized test, let's populate those parameters with real test data. And this is where the technique really starts to work, because we're getting down to the absolute concrete detail of exactly what album we're talking about in this particular case. Exactly what is its chart position, exactly how much stock have we got, exactly how much do we charge for it, and so on. So we capture one or more examples, essentially customer tests, ideally with data taken from the real world, so it's realistic data. And we use that to build, or rather to reach an explicit, precise, shared understanding between us and our customers of exactly what the software is supposed to do. So there's no room for maneuver here. There's no room for misinterpretation. And in the process of doing that, we spot misunderstandings and we can clear them up very, very quickly. So that investment in the customer's time and in our time up front before we start writing code tends to pay dividends by an order of magnitude downstream, saving time on fixing those misunderstandings in working delivered software. So it's a very, very powerful technique. It also gives us opportunities to have a kind of a negotiation about the scope of the requirements. So, for example, if we're going through a user story and we're finding that there are dozens and dozens and dozens of test cases we need to handle, maybe that's when we have the conversation about how could we simplify this. Maybe we could break it down into multiple user stories and say, well, look, we'll do this test case for now, we'll do this scenario, and then in the next iteration we'll work on one of the other scenarios. Or maybe we could simplify the design and say, well, what if we took out one of the variables here, so the number of different combinations of inputs we need to handle is much reduced. So there are often ways that we can simplify the design, and this is usually the first time that the true complexity of a requirement becomes visible. This is the equivalent in sort of movie terms of, if you've got, in the script might be one line that says, and then 100,000 giant robots come storming over the hill, but that might turn out to be like 6 months of shooting. Even though it's only one line in the script. And it's often the same with requirements. It might sound very simple when it's written on a piece of card, but then we actually start delving into all the scenarios that we would need to handle. The complexity and the number of inputs and the number of outputs starts to become more clear. So it's a great time to have those conversations as well. And not just between us and the customer, but between everyone involved. So these scenarios, these examples are very, very useful, for example, for people doing user experience design, or for people doing handling information security. So the number of teams that people I know working in InfoSec who complain to me that they typically get involved after they've built the software or very long, down the road, when a lot of things that could have been fixed just by changing the design would have been much easier. So get them involved now. So, for example, there's a whole can of worms here, for example, with our payment information. So get them involved early, show them the scenarios. You don't necessarily need to all be in the same room at the same time, but this is a conversation piece that everyone can get around at some point and have conversations early in the design process, certainly much earlier in the design process, that will save us a lot of time downstream. Now, I appreciate that this can be a little political because customers' time is often valuable, and they're often unwilling to give up the time, to invest this time up front with us. Now, it's in their best interests to do that. It really is, because if they're spending a lot of money on a piece of software, and they probably are, their choices are how much software, how many features, how much value will they get for their money. If they do this the hard way, if they expect us to go off and kind of make it up as we go along, or to be psychic and interpret somehow what they want, they're going to end up wasting a lot of that money downstream that could have been spent on adding more value. So it really is in their interest, but often they don't see it that way. They just feel the pain of being dragged aside all the time. So the more painless you can make that, the better. I'd highly recommend cake or beer or whatever. You would entice them in some way. Make it a pleasant experience. That's very, very important, that you are approachable, that you have, as we say, as doctors would say, a good bedside manner. So they want to get involved and they enjoy these sessions and they see the value in them. But if all of that fails, and they're not willing, for example, to empower someone else to play that role, because it is a role that has to be played, it's very important. They're not willing to, to promote someone or put someone in that place that can make these kind of decisions on their behalf. Then there may be a little bit of tough love is required. And what I've had to do on projects before as the tech lead is I've had to educate, because sometimes customers need training. I've had to educate the customer on what happens when we haven't agreed tests. And when I'm in charge, what happens is we don't deliver any software. They need to get their head around the idea that if we haven't agreed a test for it, they're not going to get it. And sometimes you have to be school of hard knocks like that and say, look, it might take a couple of weeks for them to figure out how this process works and what their role is, isn't it? Because if they don't play that role, there's a very considerable chance that you're going to run into real difficulties, and it's going to end up costing a lot of money. So you need to be cruel to be kind sometimes, but it's better to just be kind to be kind. So if you can find ways to entice them or to make it easy for them, then get your heads together, use your imaginations. If you have buy-in from senior management, that really helps. Maybe they will give you budget for that kind of stuff. So anything you can do to make it easier. Now, I've captured these in spreadsheets. You probably will be aware that there are tools, dedicated tools, available for doing this in as well, with names like Cucumber and various other edible products. There's a very popular one based on Cucumber for the .NET platform called SpecFlow. And they follow a similar kind of pattern. So you create specifications for features, and those features have scenarios, and for each scenario we can capture examples that kind of fill in the variables, fill in the parameters for each of these scenarios. And then from these specifications, the tools will automatically generate sort of skeletons of test fixtures that we can then fill in and start doing our test-driven development. Now, that's all very, very useful, but I know a lot of teams who are using these tools. They're often referred to as BDD tools, behavior-driven development tools. They're using tools like Cucumber, but they're writing the tests themselves. They're not having that dialogue with the customer. And I think maybe sometimes we get a bit too bogged down in the tools. The way that we used to do this is we would maybe use a spreadsheet, because customers often know how to use a spreadsheet as well, and we would capture it in a format a bit like this. Maybe we would make it look a little more presentable. And then I would literally copy and paste the data out of the spreadsheets into test fixtures, because that's essentially all we're doing. It's just that some people have it done automated. Don't get bogged down in the automation side of it. Don't get bogged down in these tools. They are useful and they can certainly speed things up. But to be quite honest, it might take me a few hours to write a VBA, an Excel macro that actually generates n-unit tests based on these scenarios. We just said, okay, well, look, let's take this this range here and say, okay, now use these as field names, for example, or parameter names for a parameterized test, and use these as the values with some interpretation going there about type and so on. Is it a string? Is it a number? And so forth. So a bit of translation happening. So it wouldn't actually be there. It's not costing us an enormous amount of time, to be honest. That's what I'm trying to say. What costs us the time is all those misunderstandings about the requirements. That's where the real time goes. And that's why it's this process of working directly with our customers, agreeing explicit, precise examples of exactly what they're expecting the software to do, and reaching that shared understanding is what this is all about. So that's what we're going to be doing. We're going to be copying and pasting this data into our end unit test fixtures. And what I'm going to do is because I'm a TDD kind of cat, if you watch the previous videos, it is bog standard vanilla test-driven development. I'm not going to be doing anything special. So red, green, refactor, each of my tests is only going to ask one question. So I'll have for example, for the end stock, there'll be a test for what that is. There'll be a test for what that is, and so on. There's going to be refactoring and all sorts of internal design going on while I'm doing it. I'm going to be writing unit tests, so these aren't going to be browser-based tests or front-end tests in any kind of way. And I'm going to be, for any details or any external dependencies that I don't want to think about yet, working from the outside in, as I like to do, I'm going to use stubs or mocks to pretend to be those things. I'm going to fake it until I make it. So I can drive a simple design from the outside in using unit tests in a test-driven way, but very importantly, based on the customer's test, driven directly by the customer tests. So these represent the meaningful tests in our test list. This is where they should really come from. So let's do some TDD just to get us started. So I've got the beginnings of my test fixture here. Now I'm applying a convention here. You can apply whatever convention makes sense to you. But I'm putting all of the, each of my scenarios is going to get its own end unit fixture, as we'll see. And each of those fixtures is going to be packaged together in a folder named after the feature or the user story or the use case that I'm testing here. So you don't have to follow this particular scenario. But that's just the way I've done it, so that it just makes it a bit easier. If people are going, well, which customer test is this? Well, it's written on the test. Okay, so the test is named after the scenario, the test fixture, and I'm going to name the test after the part of the then clause, after the outcome, and the way the customer described it. So the first one is, one copy is deducted from the CD's stock. So one copy is deducted. We can remove some of the noise words from CD stock. Okay, and again, you could probably imagine how that might be generated automatically if you were to write a tool to do that, which many people have. Okay, and it's TDD, so let's write the assertion first and work backwards. And what we're saying is that the finishing stock should be 9. So let's imagine that a CD is an object that we can query. Let's work backwards from there. Oops. Let's declare that type. There we go, lovely. And let's give it a stock property. Make it a get-only property, there we go, for now. And we'll make that an int, it's an integer. Thank you very much. And now let's initialize CD with stock of 10. Okay. Let's create the constructor for that. And we'll call that stock. That's our input stock. There we go. And what we're going to do now is we're going to buy the CD. So you will note, we'll come to it in a minute, but I am ignoring all of the other inputs and outputs. They've got nothing to do with this particular test at the moment. So we buy, that's all we need to know. So I don't need to provide credit card details because we're not thinking about that yet. So it is TDD in the sense that I'm trying to make as few design decisions as possible with each test. So we're going to add a bit more and then add a bit more and then add a bit more. Okay, let's buy that. Okay, now let's run that and see it fail. There we go, expected 9 but was 0. Now, we're in TDD mode here, so we're working on one particular customer test, which is about the stock being 9 when we've finished. And we've got a couple of choices about how we approach this. if I thought it was a bit fiddly or a bit complicated, I might decide to triangulate that. So I might work through a number of examples that may be examples that I've dreamed up. Or in this case, we could use the customer's second example there. So we're expecting the end stock to be 4 if we start with the stock of 5. So we could triangulate, which would mean that I would just say, okay, when we buy a CD, can I do it this way? Will that do it? We'll soon find out. So we could triangulate like that, and then we'll do another test case. So just like we were doing in the first video in this series, when we're doing test-driven development, you might start with a simple example and just hard-code a result, and then add another example and generalize that. And that's what Kent Beck refers to as triangulating. But sometimes the implementation is obvious. And when the implementation is obvious, we should just do the obvious implementation. No need to triangulate. So what I'm going to do is just initialize our property stock. Okay. And then what we need to do is we need to deduct one from the stock. Now we can't do that at the moment because we need a setter to do that. So let's add a private setter. So when the implementation is obvious, just do the obvious implementation. But if the implementation is not obvious, triangulate. That's TDD. Okay, that's looking good. Now let's think about some refactoring. Well, this doesn't really belong here. So let's move that to another file initially. Okay, we can add that to version control and check that that's worked. And I think probably this is in the wrong, probably needs its own project. This shouldn't really be in the test project at all. So let's create a class library for that, and let's call it CD Warehouse. And it's saying it already exists. It does not. I've got a feeling the reason for that is, yep, I said delete project and it just removed it. Let's fix that. Let's try again, shall we? Thank you. This is what happens when you're on take 3. Okay. We don't need this class here, so let's delete that. And then let's move our domain object there into the CD Warehouse project. Okay. And we can fix namespace there. That's jolly handy automated refactorings. If you're in Visual Studio, hopefully you've learned about the joy that is ReSharper. I can't imagine Visual Studio without it. This is why we have tests, because and that's not very helpful. Seems to think it's already got a reference to it. Let's remove that. Okay. Let's try again, shall we? The joys of .NET. Thank you very much. And we're back in the room. That took a little longer than expected. Okay, let's go back to our tests. So that's one test passing. We've done a bit of refactoring there. So we're discovering the internal design here. In that particular test, I've only dealt with the design details that are pertinent to that particular outcome. As we go, as I add more tests, we're going to be adding more information to our CD. And we're also going to be adding objects, or in this case, just interfaces that will handle payment processing and notifying the charts and so on and so forth. But for now, what I tend to do in my habit is work through these examples one column at a time. So I do that example and then that example. And then I would move on to the next column and do that example, that example. So these would probably end up as parameterized tests. In actual fact, because of the way that we've got multiple tests with 2 examples, so each example has 3 tests associated with it, we're probably going to actually parameterize the whole test fixture, and as we go we're going to flesh out and add more and more design details. So I'm going to pause the video here and I'm going to show you what this code might look like after I've actually automated all of the tests for both of these examples. So here is the completed test fixture for the scenario that I was working on. You see we've got 3 unique tests, one for each of those outcomes. And if we scroll up a little further, what you'll see is they all have a shared setup. So it's essentially the same action with both outcomes. And you'll notice that this whole fixture is effectively parameterized. You can do, if you weren't aware that you could do this, I only found out quite recently, you can actually parameterize a test fixture in NUnit using the test fixture attribute. So test fixture can take parameters, and if they match in terms of order and type, the parameters of the constructor of that test fixture, then it will feed them in. So if we just run this test, you'll see there we've got essentially 2 test runs, 2 test fixture runs, each with 3 tests. And you can see also there the data that was actually passed into that run. The data was literally copied and pasted from our spreadsheet. And you'll notice also that all of the fields and parameter names and et cetera, and the names of the tests match directly what they were called by the customer in the test. So you can probably easily imagine how this might be generated automatically as well. But even if you're not generating automatically, it's very important to be driven by the customer's test. 2 other things I just wanted to quickly point out here. You'll notice, as I mentioned before, our payment system is a mock. It's not real, just an interface. And our charts system there also is a mock. So we haven't actually got to those parts yet. We are faking them until we make them. They may even be parts of other projects or other systems. So we're going to fake it till we make it. Our goal here is not to write, because people often mistakenly refer to these as acceptance tests or system tests. That's not what they're supposed to be. They are the exact same kind of tests that we've been using to do TDD with throughout these videos. So they are about the internal design. External dependencies are excluded. We stub and mock those. We're also using stubs and mocks to fake things until we make them. So if there are details of this design that we haven't got to yet, or we don't want to think about yet, we can just define an interface and write a test that uses a mock or a stub with that interface. And then what we would do is we would work our way inwards from the outside in into the internal design. So I might start writing tests, unit tests, for example, for an implementation of iCharts or an implementation of iPayments. And that might be in its own project, or certainly would probably be in its own package. But that would have essentially its own API and its own tests, however you choose to package those things up. So it is recognizably TDD. The only big difference really is, where do the tests come from? And the answer is they come from the customer. Have that conversation. If the customer doesn't want to have that conversation, do what you can to try and entice them, or to make it easier for them, or to make it more pleasant for them. It is very, very important that you have a good, honest, trustworthy working relationship with your customer. So don't BS them or anything like that. It also helps enormously, and I know this is very chicken and egg. It helps to be able to, if you're delivering reliably, you win your customers' trust, and they're far more likely to get involved and give you what you need. And I appreciate that is very much a catch-22 kind of chicken and egg situation there. But whatever you can to do to win their trust is very important. And if all else fails, I personally dig my heels in and say, well, okay, if they're not going to engage, work stops. Because that is such a big factor in the successful failure of software development that I would rather not. It's like if you've got a patient who's booked in for a heart operation or needs a heart operation, but they won't quit smoking or whatever. It's like, no. If you're not gonna work with me, we can't work with you. And that's kind of how I feel about that relationship between developers and their customer. Now, there are ways around it. If the customer, for example, is a senior manager and they're too busy and too important, maybe they can delegate. But when I say delegate, I mean empower somebody to make those decisions. Not empower someone to go in the meeting and take notes and relay messages from the real customer, because that's of no help at all. That just slows everything down. It becomes another person getting in the way. So they need to be empowered to actually be the customer and to make those decisions. And again, trust comes into that a lot. Specification by example, if it's done well, is a great way to earn trust. But I do appreciate that you have to kind of find a way to put yourself. They need to suspend their disbelief for a short amount of time, maybe a month or so, to give you a chance to show them how it works and that it can work. So there you go. That's specification by example. I'm a great believer in it. I think it is the ultimate driver of TDD. It is the answer to the question, what tests should we write? Well, we should write these tests, the customer's tests. You can totally approach it using specialist tools, but be very careful that those tools are actually generating fast-running tests, unit tests. Some of these tools are actually pulling the data in at runtime. They're reading it from files or from wiki pages or from spreadsheets at runtime, and they end up running really, really slow. And remember, these are not supposed to be system tests or integration tests. They need to be fast-running tests because they are going to be your regression tests. One final thing I'm going to mention. There are many differing opinions on how we approach this whole process, and in particular on what happens to our... I've closed it there before the benefit of version control. Let's open it again. So people ask, well, what happens to these after we've delivered the software? In my experience, after the software has actually been delivered, they have very little value. They are a record of what we agreed. And if you wish to keep them as a record of what was agreed, then by all means, fill your boots. But like all documentation, they very quickly start to get out of step with the code and they have to be maintained. They carry an overhead. Now, if you're using a tool that keeps these in step, that helps. So tools like Cucumber and SpecFlow can help keep it all in step, your documentation and your test fixtures, and therefore the design of your software. But it is still quite the overhead to be carrying around. My personal opinion is that I stick them in an archive. I don't throw them away, I archive them. So they are there for our records. But they are a record of something the customer wanted the software to do that it currently doesn't. That's what I think of as a spec. If you want to know what the software does now, go look at the software. That's your best guide, really, is go look at the software. Or if you're a developer, go read the code. Or go read the tests. Now, bearing in mind, if you do it in a smart way and you follow a convention, there's a chance that you can end up with test fixtures that are logically equivalent to your customer tests in this kind of way, if you follow certain conventions. And therefore, you can maybe treat these as the ultimate spec. This is what the software is supposed to do, because if it doesn't, these will fail. So again, don't get too bogged down in the tools. Don't get too bogged down in the specs. In TDD, the tests are the specs. Once we've delivered it, there's very often not a need to go back with the customer and revisit the original requirement. It's usually much easier to just run the software and show it to them and say, well, this is what it currently does and what would you like it to do now? So I don't want you to think that the whole point of this process is to end up with thousands and thousands of these specs that you then need to maintain and look after. The most important thing is working software. And the second most important thing, by working, I mean what the customer wanted. And the second most important thing is tests that will let you know if that software is broken. So fast running automated tests. And if you've got those, and you're delivering working software, you're in pretty good shape. So there you go. That's spec by example. It comes by many names, including test-driven development, but also behavior-driven development, acceptance test-driven development, whatever you want to call it. The idea is that we work with our customer to agree examples so that we build a shared understanding of exactly what the code is supposed to do. And that helps us eliminate a lot of misunderstandings, a lot of potentially very costly misunderstandings, which frees up a lot of time downstream, which means we deliver a lot more value, a lot more bang for the buck.